As a way of reminder, let's quickly look at what we discussed last week. As you can see, we discussed, I wanted to share that of Unit 4. As you can see, this is cement. I hope you are seeing what I'm sharing. This is cement. We talk about the definition of cement, its properties, and brief historical background or how cement came to be. We also talk about the raw materials used in the production of cement. And if you can still recollect, we talk about two types of raw materials. And the first one is lime-containing materials, such as limestone, marble, oyster shells, mark, chalk, etc. Then we talked about clay and clay-like materials. From there, we move on to the production processes of cement. And when you're talking about that, the first step in the production processes of cement is quarrying, dredging, and digging. Then you move on to grinding. From grinding, you move on to blending. From blending, you move on to fine grinding. And under that fine grinding, there are two processes there, the wet process or the dry process. From there, we go to burning. And from burning, we go to finish grinding, which is the last step in the processing of cement. And after the production of cement, the next thing is to package and ship the cement to the appropriate quarters for distribution to various markets. Then this is the basic component of cement production process. As you can see, the limestone, the clay, they blend them together. From there, they are sent to the kiln. From the kiln to cleaner store, then from cleaner store to the cement mill, where the final process takes place. We also show the diagrammatic expression of cement production process. All the one we've mentioned theoretically, this is the diagram. From the raw mill to the cement mill. After which the cement is produced, it is now stored in the cement silo. Then we also talk about the uses of cement. We talk about the environmental health and safety risk involved in cement production. So that is about brief revision of what we did last week. Today, I ask you to read about fertilizer. Fertilizer. I don't know how many of you have read fertilizer. This has always been the practice of this class. Anytime you are asked to read beforehand, you do not treat the directive with dispatch. You always neglect the directive. And ever since we started this online facilitation, you are one or two of you have been the ones attending this class. Your lackadaisical attitude cannot deter us from doing the needful. So let me go ahead to share what we have for today as our lesson. I told you to read fertilizer. Fertilizer. You can see on your screen. Fertilizer. So I formally welcome you to Unit 5 of Module 2. We've revised what we did in Unit 4, where we discussed cement. And then in this Unit 5, we shall be discussing fertilizer. By the end of this lesson, you are expected to be able to explain fully the meaning of cement, the meaning and importance of fertilizer rather to life. Then you also be able to itemize the raw materials used in production of cement. The raw materials used in the production of cement. Fertilizer rather. Sorry for the mixed up. Then you should be able to list and explain the processes involved in the manufacturing of fertilizer. Once again, you should be able to explain fully the meaning and importance of fertilizer to life, itemize the raw materials used in the production of fertilizer, list and explain the processes involved in the manufacturing of fertilizer. Now, what is fertilizer? Who among you can tell us the meaning of fertilizer? What is fertilizer? I want somebody to tell us the meaning of fertilizer, please. What is fertilizer? What is fertilizer? Anyway, fertilizer is a substance added to soil to improve plant growth and yield. It was first used by ancient farmers. Fertilizer technology developed significantly as the chemical needs of growing plants were discovered. From that simple definition, when you want your farm products you planted, you want it to grow healthily and at a very fast measure, you apply fertilizer to it. Modern synthetic fertilizers are composed mainly of nitrogen, phosphorus, and potassium compounds with secondary nutrients added. The use of synthetic fertilizers has significantly improved the quality and quantity of the food available today. Fertilizer replace the chemical components that are taken from the soil by growing plants. However, they are also designed to improve the growing potential of soil, and fertilizers can create a better growing environment than natural soil. What I'm saying that the soil has its own nutrients. It's not as if the nutrients produced by soil are not good. It's not as if they do not add to the health of the growing plant. But it's not as fast as the synthetic fertilizer. They can also be tailored to suit the type of crop that is being grown. Typically, fertilizers are composed of nitrogen, phosphorus, and potassium compounds. They also contain trace elements that improve the growth of plants. Having known the definition of fertilizer, what are the raw materials being used in the manufacturing of fertilizer? What are the raw materials? The compound fertilizer composed of primary fertilizers and secondary nutrients. These are primary fertilizer. These include substances derived from nitrogen, phosphorus, and potassium. Nitrogen, phosphorus, and NPK. Various raw materials are used to produce these compounds. When ammonia is used as a nitrogen source in a fertilizer, one method of synthetic production requires the use of natural gas and air. Then the secondary nutrients. These are added to some fertilizers to help make them more effective. Calcium is obtained from limestone, which contains calcium carbonate, calcium sulfate, and calcium magnesium carbonate. The magnesium salt is fertilizer. In fertilizer, is derived from dolomite. Sulfur is another material that is mined and added to fertilizers. Other mined materials include iron from ferrous sulfate, copper, and molybdenum from the molybdenum oxide. Production through manufacturing processes. That is, what are the processes involved in the production of fertilizer, that is synthetic fertilizer? What are the processes involved? Nitrogen fertilizer component. Ammonia is one nitrogen fertilizer component that can be synthesized from inexpensive raw material. Since nitrogen makes up a significant portion of the Earth's atmosphere, a process was developed to produce ammonia from air. In this process, natural gas and steam are pumped into a large vessel. The next step is air is pumped into the system, and oxygen is removed by the burning of natural gas and steam. When the natural gas and the steam are burned, the oxygen is removed. This leaves primarily nitrogen, hydrogen, and carbon dioxide. The carbon dioxide is removed, and ammonia is produced by introducing an electric current into the system. The second step, nitric acid and ammonia are used to make ammonium nitrate. This material is a good fertilizer component because it has a high concentration of nitrogen. The two materials are mixed in a tank, and a neutralization reaction occurs. And this neutralization reaction produces ammonium nitrate. This material can then be stored until it is ready to be granulated and blended with the other fertilizer components. Still on the production to manufacturing processes of fertilizer. Phosphorus fertilizer components. Some of the phosphoric acid is also reacted with ammonia in a